in this example, we have a couple of amplifiers connected in cascade, and also we have the output looping into the first one from a couple of places and also to the second one in here. And what we're being asked to do is to figure out a correlation or find V naught in terms of V1 and V2, basically to figure out what this particular configuration is doing in terms of V1 and V2. Alright, so what I will do is I'll highlight what I know and I don't know. And what I know, for example, in here, and actually let me just write them. Of course, the current in here is IN is 0, and I'm going to call it IN1, and I'm going to call this A1. The IP1 is also 0. This one here is IN2 is 0, and this one here is IP2 is 0. And we know that this point in here is 0, and it will happen, I'm going to call this one here is also 0 volts. Okay, so do I know anything else? I don't believe I know the voltage in this point or this point. Okay, I don't know that voltage, so I'll have to figure it out. So let's call them here. So what I will do is I'll say, well, this point in here is called 3. Okay, so I will try to find voltage, and I'm going to call it, for example, V3. And if I find this V3, it's the same as this one here at point 1. Okay, I'm going to call it also V3 because they're exactly the same point because of the virtual short. Okay, so this one here is V3 and this one here is V3. I just called it because this one here I called it V3. Okay, so I'm going to highlight what I don't know, and this one is in here. Let's just double check. So we don't know that V3 in here or this V3 in here. Okay, what else don't we know? Well, we don't know what VA is in here, this particular one. So what we have to do is we have to highlight that we don't know this point either. We do know this point in here. We know the voltage in here. Okay, and we don't know this voltage in here. All right, so let me just do this here. I have highlighted. The reason why I removed the highlight because I don't know V3, I don't know VA, and I don't know V naught. And that's what I'm after. Do I know V2? I do. Other voltages that I don't know, these are the same, so they're exactly the same. I think that's it. So the thing I highlighted are 1, 2, and 3. So I have 3 unknowns. That means I need to write 3 equations. So let's try to figure out where these 3 equations are. But before I do, let me just highlight what I don't know. What I'm after, I need to write equations to figure out V3, I need to write the equation to figure out VA, and I need to write an equation to figure out what V naught is. And V naught is what I'm after all. Okay. So I'll remove the highlights in here, and the reason why I'm removing the highlight is because I'm going to try to identify where should I be writing nodal analysis equations. I shouldn't be writing nodal here or here, and the reason why is because in both cases I have the current leaving the amplifier and I don't know. Okay, so what I have to do is I have to identify 3 other locations where I can write nodal analysis. I believe one of them should be here, okay, because this is where the V I'm looking for, and another one should be probably here as well, even though I know that this voltage is 0, but I should be able to write the nodal analysis. It will just help me. And the third equation is probably going to be here, and these are basically the essential nodes that are left. You might be tempted to write it an equation here. You shouldn't, because this is exactly the same as this point, and I don't know this current leaving from here. And I believe I identified the places where I should be writing these equations, and they're numbered 1, 2, and 3. So let me just go ahead and basically start writing equations. So for example, at node 1, what I will do is I'll say, okay, that's basically V3. Let me just highlight it in here or zoom out a little bit. So we have V3 minus V1. That's what we're after. Okay, and that is divided by the R1, which is 4, and then plus V3 minus VA divided by the R2, which is 2 kilo ohm, plus I believe it should be V3 minus V output divided by R3, which is 2 kilo ohms. Okay, just to make sure that you understand the last one. So what I done is this is the first current, this is the out, and then the second current is actually the current from here to here. Let me just highlight it. It's this current in here, okay, and then that's this. And the last one, it's actually between this, which is across the R3, and this one here is the same as the V naught, and that's what we have in here. So this equation now contains 3 unknowns: V1, V3, and I called it V1, where is the V1? V3 minus V1. Well, V1, yes. V1 is not an unknown. V1 is one of the inputs. So remember, so what we're trying to do is we're going to keep V1 and V2. The final equations of V0 should include V1 and V2. So we're going to leave it as a known entity. All right, so we'll clean these a little bit. I'll multiply both sides by 4. So that will give me V3 minus V1 plus 2V3 minus 2VA plus 2v3 minus 2v output equals 0. All right, and that will result in the following. So we're going to do this here. I'll write it in terms of, I believe I'm going to keep v1 and v0 on one side and the rest on the other side. Or maybe let's keep everything in one side and we'll figure it out towards the end, okay? All right, so what I will do is I'll say negative v1. That's the only one I have in here. Let me just highlight the thing I know. Negative v1 and I believe negative 2va. Okay, and that's here. And that leaves me with v3. And the v3 is I have 1, 2, plus 2. Hold on. This, well, this goes with that. No, actually, this becomes 4. 4 plus, that's 5 v3. And then I have taken 2, 4, and 3, and that leaves me with negative 2 v output equals 0. All right, so let me just highlight that. This is the equation that I want. This is the first equation out of 3. All right, so let's write equation now at 2. Okay, so point 2 is here. Let's write the equation, a nodal analysis equation there. So that will leave me of 0 minus VA divided by the 4 kilo ohm, or the R4, which is 1 kilo ohm, plus, I believe that should be 0 volts minus V naught divided by the R5, which is 2 kilo ohms, and that's basically it, and that should be equal to 0. So I can just multiply both sides by 2. That will be negative 2 VA negative V naught equals 0. I'll multiply both sides by negative 1, and that's basically the second equation in here. So that's the second equation. All right, so we write the third equation at node 3, which is right, I believe it's here. We didn't write any equation in here, so let's do that. Okay, I will drag these down so that I don't have to zoom out so much, so you should be able to see what I have. Okay, here. Okay, so that leaves us now equation here. So that will become V3 minus V2, and V2 is not an unknown, it's something I'm going to keep, divided by 3, plus V3 divided by the R7, which is the 2 kilo ohms, plus I believe it should be V3 minus V naught divided by the R8, which is the 6 kilo ohms, equals 0. So let me just make sure highlighted. So we got this one here, and then we got this one in here, and then we got this current actually in here, and of course there's no current flowing from here. I can't assume that this current is 0 because there might be a current in here. The current in here is 0, but not necessarily here. All right, so we'll clean them up. So multiply both sides by 6. That will give me 2v3 minus 2v2 plus 3v3 plus v3 minus v naught equals 0. So let's sum them up, and that will give me, let me just do this here, 2v3 and 3v3 and 1v3. That will be 6v3 minus 2v2 minus v naught equals 0. So let me just highlight that. That's the third equation. So let me just do this here. So I'll have now come up with 3 different equations. I'll put them right next to each other so that we'll figure out what to do, because my ultimate goal is to figure out V naught in terms of V1 and V2. Okay, so here are the equations that we got in order. We got this one here first from node 1, this is from node 2, this is from node 3, and I have just written what are the unknowns are. V3, VA, and V naught are unknowns. Regardless of the circuit, we're just solving math at this point. So that means the equations at the end of the day, they should not include V3, VA, or V naught, because what we're looking for is V naught in terms of V1 and V2. So yes, well, V naught is what we're looking for, so we're going to keep this, but I don't care about V3 or VA at this point. They're just unknowns, so they're secondary. Now, what I have in here is I have V naught and I have V1, so I need to get rid of the VA and the V3. I just need to get rid of these, and what I'll do is I'll just say, well, I can write VA in terms of V naught, and that's simply negative 0.5 V naught. That will be the VA. Let me just do this here so that I can, whenever I see a VA, I'm writing those in terms of the V naught. So V3 in terms of V naught and V1 and V2. That's what I'm trying to do. In this particular case now, whenever I see a VA, I'll just replace it with its equivalent in terms of V naught. Similarly in here, what I need to do is I need to get rid of the V3. So I will say, well, V3 is simply 2V2 plus V naught divided by 6. Okay, and that should be equal to 2 divided by 6, and which is 1/3 V2 plus 1/6 of V0, and that's V3. All right, so now whenever we see a V3, we just substitute it with this particular value and it will become in V2 and V1. So what I will do is I'll take this one and substitute it in here, and I'll take this one also and substitute it in here. So this way I'll get rid of the VA and the V3, and everything will be in terms of V1 and V0 and V2, okay? All right, so that will become negative V1, that's what I'm looking for, negative 2 VA, and that will be multiplied by negative 0.5 V0, and plus 5 V3, and I don't need V3, so what I will do is I substitute it by 1/3 V2 plus 1/6 of V0, negative 2 V0 equals 0, and now I have everything in terms of V1, V2, and V0, so I want to move V0 on one side and V1 and V2 on the other side, and that will result in the following, which is V0 after I've done all the algebra and moved them around. So basically I have V1 and V2 on one side and V0 on the other side. So that's basically how V0 is affected. So this particular combination of two amplifiers, all it does is basically amplifies V1 by 6 and in inversion, and amplifies V2 by 10 in inversion, and then it sums them. That's basically what this particular combination of two amplifiers and all these resistors around them do.